Okay, let's before we get to the reaction, let's get to know aldehyde and ketones. Okay, the reaction that we can do on aldehyde and ketones is called nucleophilic addition. Okay, so we're gonna add a nucleophile onto aldehyde and ketone onto a carbonyl carbon. Okay, the carbonyl carbon is electropositive for two reasons. One, inductive effect. Oxygen is more electronegative, carbon become electropositive. We know all that stuff. Okay, or through resonance effect. All right. So my point is that carbon, the carbonyl carbon, is electropositive. If you add a nucleophilic species, the one that has a negative charge, it can attack on the carbonyl carbon. Okay. And number two, the carbonyl carbon is prochiral. What does prochiral means? Well, it's not chiral yet. Okay. After the nucleophile attack, if you end up with 4 substituents, you'll get a chiral center. All right. But now, since this carbon and sp2 carbon, so it's trigonoplanar, you can see it's flat. I'm trying to draw it flat right here. Okay. Think about like carbocation. Nucleophile can attack on one side, can attack on the other side, the opposite side, and you get another one. Okay, so you can get up to 2 products. Okay, and they are stereoisomers. What is the stereo relationship between these 2 products? Okay, so if you can't really see it, all right, I'm gonna rotate this guy right here. Was it counterclockwise? Okay, so let's go like that. Here we go. So they are mirror images. Okay, so they are enantiomers. Okay, all right. Between aldehyde and ketone, aldehyde is more reactive than ketone. Do you want to guess why? Aldehyde is more reactive for this reason. Let's take a look at the resonance structures. Okay, so CO double bond is polarized, so you can draw the resonance structures like this. You can see that the carbonyl carbon has the carbocation character. Okay. If some of you may remember, all right, what stabilizes the carbocation? Well, you might think about hyperconjugation. The ketone have more hyperconjugation, okay, compared to aldehyde, because aldehyde got only one H right there. Okay, so aldehyde is less stable. Right? Carbocation is less stable than the ketone. So less stable means more reactive. So aldehyde is more reactive than a ketone. Okay. Not only that, I'll take a look. So that's another reason why aldehyde is more reactive than ketone. This one's steric hindrance. Okay, ketone contain 2 substituents. Okay, 2 alkyl chain, and alkyl chain can block the nucleophilic attack. Okay. Anyway, aldehyde ketones are generally reactive. These are nucleophiles that can react with aldehyde and ketone. Just a bunch of them. Okay. All right. One thing you should know. Well, of course, this is like one reaction. This is one reaction with reaction with water, reaction with alcohol, reaction with dialcohol, thioamines. You can count how many reactions you have to learn. Okay. But now, looks like there are a lot of reactions that you will see in this chapter, but it's not entirely true. Many of these reactions have the same mechanism, so I'm going to group them like this. Okay, this is one reaction. This kind of 2, maybe 1.5. Sulfur, oxygen do the same thing, so put them together with an alcohol. Okay, maybe this is a second reaction, amines, nitrogen nucleophile, carbon nucleophile number 4, and then hydride nucleophile number 5. And guess what? Carbon ion and hydride, especially these three have the same mechanism. So, okay. So it depends on you. If you want to like learn it separately, or you want to try to group them, recognize the patterns, I'll leave it up to you. Okay. All right. Before we get to the first reaction, let's talk about the mechanistic patterns. Okay, all of it's going to have very similar mechanistic patterns. Let's take a look on the next video.